Okay, fantastic. So we'll talk about MySQL 8 today, and because that is a shorter version of my usual presentation, we will just scrap all the stuff which are for developers and only focus on ops. Now, MySQL 8 has been making a great strides in getting close to GA, and it's now release candidate, but it's still not GA, and things are still being changed, right? So this is kind of based on, well, anyway, just know what things are subject to change. And so to give a credit when a credit is due, I borrowed a lot of very nice pictures from Oracle team blogs, presentations, documentation, and so on. Okay, so what are nice things in MySQL 8 for ops people? Well, there are, I think, is a lot of great stuff which are in MySQL 8 in the areas of stability, high availability, performance, security, availability, and manageability. The first one which excites me a lot is a native data dictionary, right? And this is something that is very internal, but also very important, and I would say is about 10 years overdue at this point. Right? What is all about, right? And one folks in operations would care. Now, if you look at the MySQL before MySQL 8, it would store table information in what so-called FRM files, right? One file per table. And then if you use in a DB table, it would also store a copy of information in a system tablespace, right? The problem with such setup is what this data can be getting out of sync. For example, if you would have MySQL to crash just around time when you were doing alter table, you could have this data to be out of sync, and you have a lot of fun manually recovering that. It also would not be quite atomic, right? If you do the single drop table or a name table, right, that would either really succeed or fail unless you crash. But if you have some sort of more complicated scenarios, for example, if you have drop in several tables one after another, before MySQL 8, that would not be atomic statement. You could have two of them drop successfully, then one of them found to be non-existent, you get an error, right? Boom. Half-done statement, that is not really what you would expect from other statements, and MySQL 8 fixes that. We also have, through that, much faster information schema, because now it can read from those real data dictionary instead of having to scan a lot of FRM files, and also no more MySum system table requires. And that is another reason why and how you can could potentially have non-transactional behavior in the future, right? You would be creating store procedure which goes in MySum tables. Boom, you crash it at exactly that time. MySum tables corrupted. Where the hell you're going to get there instead of store procedure? Well, no one knows. Information schema. That is a great example here, and we can see this query with a join on information schema, which used to be pretty much unusable, right? Even with relatively modest amount of tables, it could take many minutes. And if you would go to a million table in this case, it would not complete even in 40 hours, right? Now MySQL 8 is able to handle that quite efficiently. And even if you have a million table, well, it would take a little bit of time, but 78 seconds, that's still usable, right? With such a large amount of tables. UTF-8, another area where MySQL 8 got a lot of focus, and why that is important, especially right now, right? Because even if you are using some of the Western languages and generally do not or did not need UTF-8 beforehand, then now we have in all the applications, we have what? Emojis, right? And emojis require really UTF-8. So if you are having kind of, millennial-friendly applications, then you need to use UTF-8 wherever you actually need support for languages which don't feel in Latin 1. And in MySQL 8, UTF-8 MB4 becomes default, and also a lot of performance work has been done to make MySQL much faster when it comes to UTF-8. I would also be talking about the case when MySQL 8 actually becomes slower, but that is typically when you use the Latin 19 character set. Now, a lot of work has been done about security as well in MySQL 8. There is support for roles. Now, we have many different privileges instead of super privilege, right, where you can, for example, give somebody access to restart the instance, but not necessary to do some maintenance, some other maintenance stuff. There is a password history, so you can say, hey, we don't allow you to set one of your previous passwords. Authentication, in this case, has become much more secure with SHA-2 authentication, which actually uses many rounds of SHA-2, right, for password hashes to make the brute force attack much more complicated. But it also it has a very specially optimized cached version, so it can authenticate very quickly at the same time. OpenSSL is now used both as community and enterprise edition, right? So there is no this kind of confusing differences in behavior and available options. And another thing I like is what now skip grants block remote connections. In the past, we see many users would get into security incident because they need to reset the password, they start MySQL skip grants, and they forget about that. And what they get? MySQL open to all the internet and now accepting connections with no password, right? Now, that's not going to work. If you're resetting the password, it will be only MySQL accessible locally for until you recover your password and restart it back in a normal way. Encryption is also improved. In MySQL 5.7, there is a great start in the encryption which does encrypt InnoDB table spaces, but that would not encrypt things as your redo logs and undo logs stored in the system table space. In MySQL 8 fixes that, so all the information stored in the database is being encrypted. Another thing, persistent after increment. Another thing I would say about the 10 years overdue, right? So now, in this case, you would not have a case where your after increment value can be reset, to something else in some scenarios, right? And you would not be have a chance to get the duplicate IDs and stuff like that. After manage and do table space. That is another area where I think a lot of folks involved in MySQL operations had a lot of problem through years, right? What would happen before is if you have some expensive update queries or just a select query which was running for a long time, and other queries created a lot of undo space in InnoDB, you could have that space being sort of, let's say, stuck forever in the system table space, and the only way kind of to get it back would be to recreate your database. In MySQL 8, you have undo table space. Those are stored in a separate table space by default, and then it's also automatically purged. So if you need it for some space for a period of time, you use it, then all those workload completed, it will automatically shrink back. Self-tuning for InnoDB also I think is very important, especially in the cloud. Now, if you enable this option in a DB dedicated server, then you may be able to set a MySQL and it will automatically scale if your instance size in the cloud, for example, by setting at least 3 most important variables appropriately. It is not complete, and I think there could be a lot more stuff done with automatic tuning. That is a great start. Now, partial update of JSON. That is also another very important performance thing if you are storing docs, especially large documents in the MySQL, or actually even in something like MongoDB, right? Because if you're just updating one field, maybe there's a counter, maybe that's some stamp you need to update it. You don't want a whole document to be kind of completely rewritten in the database. That is very expensive. MySQL 8 can now just update that field inside the document without fetching that and storing it back. Just, have a very small point update. And also it can handle that efficiently through the replication, where you would also only log the change in a row-based replication for a JSON field, not for a whole big row if you choose so. Invisible indexes. Invisible index, that's another feature I filed many years ago. And the problem with the indexes is they're easy to add, but they're hard to drop, because it's hard to be quite sure what that index is really not needed by your application. And if you drop an index which you turned out you actually need, then you often would have queries run so slow it will cause you downtime, and then it may take you many hours to go ahead and rebuild that index back, because that's expensive, right? Now what now you can do with MySQL is instead make that index invisible, so it will be still maintained but not used by the optimizer. And if you spot what there are some queries you still have which need it, you can make it visible back instantly, right? And if it's actually not needed, you can drop it in a week or a month or wherever you think is appropriate. Simply table storage engine. That is actually one of the things how UTF-8 was optimized. It's much more efficient storage engine for internal temporary tables, which are used for many complicated group by queries. And what it provides is much more efficient storage for this temporary data, especially if you have varchar and var binary columns. Now, right now, it doesn't deal with blob and text columns. Those still would require in a DB temporary table, but those are to be fixed, as I understand. Backup logs, that's another neat feature which allow us to prevent inconsistent backups result sometimes. Right, so now you can set this special log for backup, which would ensure the backup can be taken successfully, and it would only prevent some only rare operations. Your normal traffic would not be blocked by this log instance for backup. Optimizer histograms. That gives us a detailed statistics on columns, not just indexes, and it really allows optimizer to do much better choices in many cases. And what is interesting in this case, I provide as an example, it is this statistics is stored as JSON, which makes that much more extensible. And I hope that will allow a MySQL optimizer team to roll in more statistics or different format of those histogram information without needing to redesign it completely from scratch, right, and wait for many years for a new release. Another fix or improvement in the optimizer is an improved cost model, which allows, for example, to keep an account how much data is cached versus is not, right, which you have to fetch from a disk. Here's a link with some blog post about more information, but in general that can be very important to get the good better execution plans for some workloads. In MySQL Optimizer, I'm actually some other helpful changes. I don't have a time to cover them all, so here's a link for you. An official MySQL guide. It has some more information about MySQL optimizers, MySQL 8 optimizers specifically, as well as some other features. Performance schema is getting much faster as well, and partly that is through having indexes on performance schema. The interesting thing about the indexes on performance schema is what we're actually fake indexes, and internally information schema just pretends as it has indexes, and just because it's in memory and can scan the data so quickly, that provides their much better execution plan, and it works quite neatly. It also has error instrumentations and response time histograms, both global as well as per query query digest, and also includes query examples in summary by digest, so you can actually take the query example for some slow query and run explain for you to see why is it slow. Here is example of a performance schema performance, right? Looking through the built-in sys session table, which was designed as a sort of better show process list, but unfortunately in 5.7 it wasn't usable with large number of sessions. So like 1,000 sessions would take like 30-40 seconds. That's not as much as you probably would want to wait for a show process list. Now you can see it takes a second or two, even if there is a large number of sessions available. Remote management features. I think the speaker before me mentioned and shown in action restart command, which I think is fantastic to restart the index. And another one is set persist, which is another very great command which allows us to set a variable to be persisted when the instance restarts. Because there are so many MySQL users would set the global variable to some value, right, and just not modify MyCNF, keep MySQL running for a few months, then restart it, and boom, it behaves differently, is much slower, or whatever else you may have changed, and nobody really understands why, because that change was long forgotten. With set persist, you can ensure what those things don't happen. MySQL also assumes defaults is SSD right now, which is great. Not a lot of things are done for that as of yet, but that is good, a change in direction at least. MySQL is also prepared to be able to ask as a replication master. By default, bin log is enabled, log slave updates enabled, and log expire by default, right? So you don't need to do anything, right, to prepare that to be used for configuration. Query cache is removed, right? So if you need the query cache, then you probably should be looking at proxy SQL, right? Or you may have some other caching solution in place already. Native partitioning. So generic partition is removed in MySQL 8. It was kind of substantially slower than native partitioning. And that means if you're using storage engines like MySum, which does not have a native partitioning support, then you would have to either remove partitioning to that, from that, or convert a table to InnoDB before upgrading. Resource groups. That is another cool stuff where you can essentially map some of the queries in your workload to specific CPU cores, which can A, help you to reduce the contention, but then B, it also allows you to kind of to jail some of your expensive queries, right? So for example, maybe you have some analytical queries which can be very expensive, and if you let your analytics team to run wild, they'll consume all the server resources. You can set it so they only are able to use no more than, let's say, 2 or 4 CPU cores, and that's it. We also get better performance at scale, right? You can see with MySQL, again, if you have a really big RN and a really large number of concurrently active threads, it can beat the previous MySQL versions. We also like what a lot of stuff we can use in our Percona monitoring management solution in MySQL 8, especially much faster and performance in information schema and more information available in performance schema is great and allows us to build a lot more features out there. Okay, now things which are not so great, I'll call them feature requests. The single thread performance still sucks, and we don't have a parallel query support as of yet, right? And hopefully that will get to roadmap sometime soon. Here is the graph, right, from the champion of MySQL single thread performance, Mark Callaghan, right? And actually, I cherry-picked one with the worst regression, right, guilt as charged. But you can see what for some cases we have less than half performance of in MySQL 8 as we had in MySQL 5, right? So I think that is something we would like to see some reverse, right? And it doesn't have to be this way. There is another database which is called SQLite, which is able to both add the new features in the new releases as well as have single thread performance being better release after release. And the last thing, if you guys are interested in much more information about MySQL 8 and MySQL and other open source database in general, we welcome you to come to Santa Clara in the United States. We'll have a Percona Live conference out there. Just want to let you know. And that's it. And I think I still have a whole 3 minutes for questions. Right, Fred? No questions? Yes. So, you mean information schema? Well, yes, pretty much instead of InnoDB internal data dictionary, right, and the FRM files, now we'll have just one data dictionary. Any other questions? Thoughts? What? Memory engine. What about memory engine? Well, so so the question is memory engine going to be replaced, right? So now we have this TMP table engine, which is designed for in-memory temporary tables. And those tables have a very specific workload which is needed to resolve the queries. Now, wherever that engine is going to be at a future time exposed for general purpose use, I honestly don't know. Okay, well, thank you. Yes, let's make space for Sveta.